Hello everyone and welcome back to Education Foundation. So in this video we will be looking at another example on sample problems or questions related to the perfect gas. So the question on our screen here says that 1 kg of air can be expanded between two states as it does 20 kilojoules of work and receives 16 kilojoules of heat. A second kind of expansion can be found between the same initial and final states, which requires a heat input of only 9 kilojoules. What is the change of internal energy in the first expansion, and what is the work done by the air in the second expansion? So the question, in other words, is just simply trying to tell us that in the first expansion it does 20 kilojoules of work and receives 16 kilojoules of heat, while in the second expansion it undergoes the same initial and final states but only requires the heat input of 9 kilojoules. So now the question now is telling us we should, number one, find the change of internal energy in the first expansion, and then number two, we should find the work done by the air in the second expansion. So we're going to find two things: the internal energy and then the work done. So in solving this, we are going to make use of the first law of thermodynamics, that whereby a closed system undergoes a non-cyclic process, because in this it cannot be a cyclic process because the quantity of heat transfer is not equals to the work done, so it cannot be a cyclic process. So now let's make use of the first law of thermodynamics, which states that the quantity of heat transfer minus the work done is equals to the change in internal energy. So this is the formula that we are going to be using throughout our solving in the question. Q signifies the quantity of heat transfer, the W signifies the work done, and then the delta U signifies the internal energy. So let's take note of that. Very, very important. So for the first expansion, our quantity of heat transfer, which we are going to signify that by Q subscript 1, is then equals to 16 kilojoules, while our work done, which we are going to signify by W subscript 1, is then equals to 20 kilojoules as given in the question. So now that we have our value of Q and W, we are now going to apply the first law of thermodynamics in order to find our internal energy. So delta U subscript 1 will be equals to Q subscript 1 minus W subscript 1, which will give us 16 minus 20, which equals to negative 4 kilojoules. This means that the internal energy decreased by 4 kilojoules in the first expansion. That's what this negative sign means. So now let's move over to the second expansion. You should take note that the question says that for the second expansion, the same initial and final state must be maintained. So that is to say that delta U subscript 2 will definitely be equals to delta U subscript 1, which will then give us negative 4 kilojoules. But now our quantity of heat transfer is equals to 9 kilojoules. So in order to find the work done in this second expansion, we are going to then apply the first law of thermodynamics. So applying that, it will now give us delta U subscript 2, which will then be equal to U subscript 2 minus W subscript 2. So now our next step now will be to substitute our value of delta U subscript 2 and our value of Q subscript 2
into the first law of thermodynamics.
So when we now substitute our value of delta U subscript 2, it will give us -4, which will then be equals to 9 minus the work done in the second expansion, which is represented by W subscript 2. So once we now further evaluate this, it will then be equals to W subscript 2 will then be equals to 9 plus 4, which will give us 13 kilojoules. So that is our work done in the second expansion. So in summary, our change in internal energy for the first expansion is equals to -4 kilojoules, while our work done in the second expansion is equals to 13 kilojoules. If you found this video helpful, don't forget to like, subscribe, and drop your questions in the comment section below. Thanks for watching and see you in our next video.